Thank you, Ben. Usually we have questions, concerns about how to integrate infrastructure as code with operator framework. And in Kubernetes, it's actually very crucial to understand and to be able to manage those two frameworks. So let's go back to John. John will actually quickly introduce how to use Terraform tools with the operator framework, and he will do a short demo of the Terraform provider. Go ahead, John.
Cool. Thank you very much, Cedric. Hi, everyone. It's John Seeger here. I'm VP Engineering of Enterprise Solutions at Canonical, so I lead the development of Juju and the majority of our charmed operator teams. I'm here today to talk to you about our Terraform provider, how you can use Terraform and Juju together, and why we built that integration and what the purpose of it is, given that at first glance, they might seem to do quite similar jobs. I think this has been a really, really interesting development in the Juju ecosystem, and I quite strongly believe that it's going to help people adopt Juju and use it for what it is best for, which is managing the lifecycle of applications. So if we look a bit, on that theme as for what Juju is actually for, Juju at its essence, if you boil it right down, is all about managing applications throughout their life. It's about integrating applications either within your cloud or across clouds. And it's about composing the best of open source software applications into solutions that solve real world problems, right? So it's almost never about individual charms. It's nearly always about composing lots of different charms, like, for example, Mattermost and Postgres, or WordPress and MySQL, or the various components of OpenStack. It's really about trying to go with a model that offers kind of the most flexibility with the least amount of friction and worry for the SREs who have to ultimately maintain this software. There are lots of things that Juju is not for, though, and I think a common misconception that people have is that the Terraform is in sort of precisely the same camp as tools like Terraform and Ansible. But given Juju's kind of laser focus on managing applications through its model abstractions, Juju is arguably not for kind of arbitrary tasks on your base cloud, right? Whether that be deploying a Lambda function or managing a DNS record or deploying a machine with a gold image, creating a subnet peering on Azure. All of these kind of nitty gritty, like small details that are per cloud is not really what Juju is designed for. Now, a lot of these things it will do kind of in the back end. When you ask it to deploy a charm, it's going to provision you a VM, create a network security group, do the things it needs. But you can't just arbitrarily go and create, for example, a VPC on Amazon using Juju, right? Like, it's always done in the context of deploying an application. And that can pose a few issues where you're trying to kind of incrementally adopt Juju, or perhaps just use it to deploy an application inside some pre-existing infrastructure that you may have defined. But what if you want both? Like, it's okay to want both. It's okay to say, well, we've got, 80% of our infrastructure defined using Terraform and Ansible, but we really want to take advantage of charmed Kubeflow because we want an easy way to manage an MLOps solution for our business. We don't want to kind of compose that ourselves. Charmed Kubeflow is an excellent solution, so we'd like to just integrate that with our existing pipeline. So I think personally, in order for us to be really successful with Juju, we need to cater for mixed deployments and kind of different environments and kind of give people the best chance. So that's where the Juju Terraform provider comes in. So the Juju Terraform provider assumes the presence of a Juju controller that has been bootstrapped. You can achieve that either kind of manually, or you can integrate that as part of your infrastructure as code pipeline. But once the controller is there, then Terraform can speak to it just like any other cloud, right? Like in the same way that you would speak to Azure through the Azure RM provider, you speak to Juju through the Juju provider. It allows you to create models, deploy charms, create machines, create integrations, both within the same model and across models. It allows you to manage user credentials, SSH keys, and the list of features is actually ever growing. It's one of the more kind of fast moving pieces of our ecosystem right now because it's relatively new. It worked right out the box with Terraform, just like any other provider. You can find it on the HashiCorp provider registry with all the documentation you need. So really, if you're a shop who's used to working with Terraform and you have it integrated, you should be able to get right on board. So, lots of places have adopted Terraform as their de facto way for provisioning infrastructure. and you can now just plug Juju straight into that. It's got a pretty simple onboarding. One limitation that we had with bundles, which kind of is most similar, I suppose, to how people would have reasoned about Terraform before, is we can now do cross-model relations. So you can use Juju to create, for example, an observability model where you might drop our canonical observability stack, and then you might have another model where you place your Mattermost server, and then you can cross-model relate those, even if, for example, CosLite is on Microcase and Mattermost is on LexD. It doesn't matter. Also, because of the way Terraform works and the way you can kind of mix providers in Terraform definitions, if you need to perhaps refer to some underlying cloud resource in a child config, maybe like the address of a load balancer, where you don't know the address of the load balancer until it's finished provisioning, you can do that, right? And you can embed the properties of other Terraform objects into the definitions that you're writing for your Juju application. So it kind of gives you a bit more interoperability there. And Terraform's dependency engine does a whole bunch of hard work for us here to make sure that events and deployments are sequenced, right? So that you can have Charm only deploy once, for example, a load balancer on the underlying cloud is available, or only deploy a Charm once an S3 bucket has been created, for example. So I'm going to do a short pre-recorded demo now of how this works. So what I'm going to demonstrate is deploying to a Juju controller that's bootstrapped onto Microcase. And in one model, we're going to deploy an application called Zinc, which is a kind of lightweight, modern, Elasticsearch compatible full text indexing search product. And in another model, we're going to deploy elements of the CosLite stack, so Loki, Grafana, Prometheus. And we're also going to deploy Parker, which is a continuous profiling tool that I've been playing with. And then we're going to link the two together and kind of show how that plays out. So there's a short video now. I'll kind of talk through as it runs. So essentially, I've already written a small Terraform plan, which you'll see in a minute. But the basic steps to get started are to bootstrap your Kubernetes with Juju. So that'll happen relatively quickly. It's a little bit sped up in the video, but normally within a few seconds. So this essentially makes sure that the Juju controller is running on Kubernetes, right, inside a pod. If we take a look at the demo file, you'll see there we are creating a model called Zinc, creating an application called Zinc and specifying the child. We are creating a model called Monitoring and deploying Grafana. We're deploying Prometheus. We're deploying Loki. You can see here us creating integrations, right? So between Prometheus and Parker, between Loki and Grafana. And then you can see here us creating some cross-model relations. So the file is relatively long. It's a couple of hundred lines. You can see that at the URL at the bottom of the screen if you'd like to see it later. But if we run first Terraform plan, you can see the plan can be kind of verified. You can check what's going to happen. And then you run Terraform apply, confirm that. And Terraform will go off and make all of the API requests it needs to the Juju controller and start creating those applications, deploying those charms, creating integrations, etc. Right? And it'll make sure that everything is sequenced up in the right way so that it all goes smoothly. So there we go. We've created 19 resources. And if we take a look at the models now, you can see that monitoring model, that Zinc model. And then we take a look at the status of the monitoring model first. So you can see there things are still kind of deploying, but you can see all the integrations at the bottom of the screen. And then you should also see, if we take a look at the Zinc model, we've got Zinc is still deploying. So we'll give that a couple of seconds and then we'll double check. So there you go. That's all of the monitoring components up. And there's the Zinc component up with all the relations intact. So essentially we've just deployed a full text search engine, which is kind of similar to compatible with Elasticsearch. And then we've linked that up to be scraped for metrics, have its logs collected. We can view a Grafana dashboard and we can even profile the application using, sorry, I'm just trying to skip on. There we go. So this is a kind of view that you would get from Parker. So on the left-hand side, you can see we're profiling Zinc in real time. So this is taking a kind of long, hard look at the core stack in Go and kind of testing how long it takes for various functions to execute, kind of thing. And on the right-hand side is a kind of preview of the Grafana dashboard that you'd be able to see if you logged into Grafana. And that was all in one self-contained Terraform file, a couple of hundred lines that you can check into version control and perhaps apply with something like in your CI pipeline to deploy to your infrastructure. So the Terraform provider itself is open source like the rest of Juju. You can find that at github.com/Juju/Terraform provider Juju. You can also, if you'd like to just get a play with it, you can head straight over to the Terraform kind of registry, take a look at the auto-generated docs there. And we've also added some docs to our own docs website to kind of help people get started. And that is pretty much all I have for the sort of introduction to the Terraform provider. And I believe next one is going to talk through a little bit like the development process there and some of the other third-party clients and integrations that we're working on in Juju to help people integrate it into their infrastructure. Thank you very much.
Thanks, Cedric, for having me. My name is Juan Tirado. I'm engineering manager at Canonical. Particularly, I'm working at the Juju project. And I'm here to talk to you about the many ways to run operators with Juju. Hopefully, after my presentation, you will find a potential use case that is good for you, and you will really wish to go into the details and start playing around with our Juju platform. So, just to give you a bit of context, in case you are not really aware of what Juju is, let me go for the left-hand side to the right-hand side. So, Juju really enables you to have a magnificent and easy deployment of complex solutions on a large variety of platforms. So from LXD to Kubernetes to OpenStack to bare metal using MaaS, and many of the main public cloud providers like Azure, AWS, or Google Cloud Engine, among others. So with your charms, which are this definition using the operator framework, where you can have defined your solutions or application from day 0 to day 2, Juju will enable you to have these complex solutions deployed from the left-hand side to the right-hand side. So if you really think about it, this sounds wonderful. It's a nice thing to have. But next, the big question is, how do I use Juju, right? Is Juju an API? Is a framework? Is a library? Is a program I pay somewhere? What is Juju? So hopefully I can really answer you this question. So if you are new to the Juju universe, I can tell you that your very first option is to install Juju in your machine, which is terribly easy. It's a snap package where you just simply can go to your terminal, type snap install Juju. You will have it installed in the latest version, and you will have basically all the features and nice operability provided by Juju in your machine in a matter of seconds. So if you want to have more information and start playing around, you can always go to the Juju help command, which will display all the available commands in your terminal. And if you really need more details about how to operate, how to work with Juju, the commands, the different topics and concepts Juju works with, please don't hesitate and just visit the official documentation page, which is juju.is/docs/olm. And here, just for the sake of clarity, I just put a screenshot of how Juju status looks like, right? So, but how did I get there? How could I have this kind of information, and what does it really mean? So let me just show you one of the really nice features of Juju, which is basically making things really easy, right? So I'm pretty sure that many of you have already deployed Grafana and Prometheus at some point, right? So, and you are probably familiar with all the complexity this involves and all the know-how and knowledge you really need to go and install these solutions in your, let's say, Kubernetes environment. Hopefully, Juju is simplifying this quite a lot. And these 4 lines I'm showing you will just bring you a deployment of Prometheus for Kubernetes. As you can see there, it's quite easy and straightforward. You deploy Prometheus Kubernetes, you deploy Grafana Kubernetes. These 2 commands will just simply interact with the charmhub.io webpage, which is our repository for charms. Install and deploy this in your infrastructure controlled by Juju. Next, we can just relate both solutions transparently. No need for IPs definition, no need for addresses and complex stuff. Just use Juju relate and indicate the endpoints we want to use. These endpoints are already defined in the charms and are available in the help. So no problem for that. You can always explore more in the documentation around there. So up to this point, and with these initial 3 commands, I already have my Prometheus, my Grafana already connected and ready to work, right? And next, as a terminal user, I will just simply go and just type Juju status task relations and have a summary of what's going on in my Juju controller. What do I have deployed there? What are the relation, ports, status, versions, revisions deployed there? What are my solutions doing? And what can I do next, and take decisions depending on what is my use case and what do I really want. So this is like a really, really brief summary of one way to use the Juju and one of its many features. But this is a terminal solution, right? It's an application. The very next question, and hopefully I will really answer this question, is how can I integrate Juju with my own solutions, right? I have my development environment. I have a project somewhere. I find Juju and the operator is particularly useful for my use case, and I really want to integrate with Juju. How can I do it? Well, there's a number of good ways to do this thing. So let me go first of all with a brief explanation on how is the Juju API. So every controller in Juju is accessible in port 17070 in case this is not changed in the configuration parameters. And basically, this is offering an RPC connectivity over WebSockets with 2 main entities which we can manipulate. One is the controller entity, which basically will be in charge of the machines we are running, users, permissions, more high-level kind of infrastructure kind of thing, and models, where a model is basically a collection of applications that are deployed and allocated into one of our available units, entities, or machines. All this is designed for backwards compatibility with a transparent API version negotiation between the client and the server, which basically means, in other words, that Juju controller and the Juju client doesn't really have to be running in the exactly same version. There is a negotiation which basically will try to find the most recent API version both client and server can really understand to provide this backwards compatibility. So in some sense, as you can see, Juju has its own API. So if we really want to operate with Juju, what we have to do is like operate with this API. So far, so good. But in order to make it easy for developers and users, we really need to have some level of abstraction here. So if you're a Python developer, you will be particularly interested in our Python-libjuju library, which is a collection of functionalities and which design an abstraction layer for our API in Juju. These controller and models are made accessible through Python and is available from pipe. So if you're familiar with the Python ecosystem, just type in pipe install Juju, as it is shown in the slide. You can already install this in your Python environment. And the piece of code I show here is basically a self-contained example of how to use this library, and just for you to have a feeling of how does it work. And in this example, simply what we are going to do is like we are going to connect to a model and we are going to deploy Ubuntu charm. I just simply disconnect, right? And this is a self-contained example in something less than 10 lines. So you can really see how easy it is to unleash and release all the potential that is behind Juju itself. So there are more use cases, right? Because this is just that was a simple one. So one of the main use cases we have found from our community members is that integrating Python-libjuju into their continuous integration pipelines is particularly useful for many of them. So for example, imagine we want to do something similar as I showed before. We want to deploy Prometheus, Grafana, we want to connect them, right? We want to do something in our pipeline. I don't know, you can imagine a particular use case for this. And what we're going to do is like simply use our Python-libjuju solution. So in this code, I will not go to details because I think it's particularly easy to understand what's going on. We'll just connect to a controller. We're going to create a new model. deploy our Prometheus, our Grafana, integrate or relate both applications with the corresponding endpoint. A particularly useful functionality is that we are going to wait until we find the status we are waiting for, right? In this case, we are waiting and stop the execution flow until we find the status active. And up to this point, we can really do something interesting for us. I don't know, running any particular or specific performance testing. You can mention the solutions you really want to implement there. And finally, what we can do is like destroying the model, disconnect, and keep on doing this. So this is a programmatic example of how to work with Juju using Python. So something particularly interesting in this library, as you can see, is that we are using the async.io Python library, and you can notice this because we are using the await word before every call to our function because they are asynchronous functions. So is in our roadmap something for this library in the next months? Yes, it is. As I have mentioned before, we are doing a lot of these async.io operations around. If you're familiar with Python, you will know that the async.io asynchronous functionality in Python is not particularly easy. And recently we have received many comments from our community asking for something more simple, something easier to use, and basically something that doesn't really require all these asynchronous operations that can really facilitate the life of our developers. So this is one of our main goals for the next months, to work on the simplification of this library and only use asynchronous operations when needed. Apart from that, we are working on preparing context managers, providing functionality that can really facilitate our users. One way to wait until the applications run in a certain state, or just until they have the the status they are looking for their use cases, applications, whatever. And obviously, as we always try to do, adding more examples and adding more docs to the library. In case you are interested in the Python-libjuju, apart from installing it from the pipe, remember, pipe install Juju, you can always visit our repo at GitHub in the link provided there. So this is regarding the access to the operator, how to run it using Juju and Python-libjuju. So second, what if you are a Go developer? Well, as you may probably know, Juju is entirely written in Go. So you can imagine that we already have code to access the Juju API in Go already available. This is an example I show here where you can basically see how I am connecting to a model manager and just creating a model inside that piece of code. Obviously, I've just taken a fragment of the complete code required for this. So we recommend this access in Go for those who really want to have a strong interaction with Juju. The code is documented itself. It has implicit examples that can be found inside the code. Unfortunately, there are not like external examples or documentation on how to work with this library. And everything is available in the Juju code base in the link I provided there, which is basically our GitHub repo. So as you can imagine, in this case, if you really only want to just interact with Juju for some reason into your project, you really need to take all the code base from Juju. So something we are really keen on working in the next months is to release an independent third-party library. And by independent third-party library, I mean have independent repo. We have our own code, not depending on the Juju code base, so we can make particularly easier for developers to adopt this new library, work with it. You can imagine something like Go with Juju. This is a tentative name. Obviously, this is something we have to discuss on how to call it. Again, independent from the Juju code base, so can be really live in a separated repo, documented, and with examples. So if you are really interested into this kind of libraries using Go, please don't hesitate to make us know your interest, and obviously just wait for any kind of announcement we can have on this particular topic. Again, this is something that's going to happen in the next months. So this is regarding Go, right? So as you have probably know, or if you don't know, I have the pleasure of announcing here for you that Juju has a Terraform provider, which basically is entirely designed for or oriented to DevOps, which it offers a tremendous power and amount of resources for those who can really operate their infrastructures in Terraform. So now we can provision resources, run these resources, keep your applications up to date, everything in the same place, right? Without not using any terminal, without not using any single line of code. Our latest version, which is 0.6.0, something we are particularly proud of. You can really have all these features, among others, just to mention a few of them. You can deploy and configure your applications. You can create models. You can integrate applications. You can manage, users, credentials, permissions inside the controller. So you can have your list of users who can access your controller, who can access what model, what can you do, what you cannot do. And you can provision machines using Juju. If you are not familiar with Juju, I can just let you know that using the Juju add machine command, you can allocate resources in different cloud providers and different targeting architectures or infrastructures such as LXD or micro-K8s. So with the current version of the Terraform provider, you can already provision machines using Juju. So now, just for those of you who are not really familiar with a Terraform plan, or if you are just curious about how does it look like having a Juju plan in Terraform, I just have here a brief example of the sample I've been just carrying on during this presentation. So what we are going to do is we're going to create our model, deploy Prometheus, deploy Grafana, and integrate or relate both applications using the metrics endpoint. So from the left hand side to the right hand side, you can see we have different resources. So we can have a Juju model, name staging, which is going to create a model called staging with no more options. Obviously, I'm ignoring here a lot of potential parameters like the configuration of the model, the kind of image that is going to run, etc, etc. In the middle of the slide, we have our two applications, Prometheus K8s and Grafana K8s, which are our Prometheus and Grafana channels for Kubernetes, where I'm going to indicate the model where they're going to be deployed, the name of the application I want to deploy, and just indicate the name. Again, these resources have a large number of parameters, such as the configuration, what series I want to use, if I want to use the Edge version, the beta version, there is a large number of potential items to configure in these resources. And finally, what I'm going to do is integrate both of them using the metrics endpoint, right? So if you think about this, we have not used a single line of code, not even our terminal. We are simply just deploying exactly the same example with Grafana and Prometheus, connecting them just for a text editor and running Terraform. This is just all the many examples you may find around. Obviously, I have mentioned our latest version in Terraform is version 0.6.0, which obviously is not complete. We are really happy with the current version, and we have more than 2,000 downloads from the Terraform registry, which is particularly good news, taking into consideration that we have not really made any promotion of the provider, so people are really aware of its existence and they are really using it. But what we want to keep on adding more functionality to this provider. So among many of the features and some of the most requested features we have is the feature or the possibility to add any provision machine. So just imagine you are provisioning your infrastructure on AWS, Azure, using your Terraform planning, and you can really integrate this into to your Juju controller. That's a really demanded question. Wait for resources. Some applications may depend on other applications during the deployment. So one way to really indicate these situations in our Terraform planning, define controllers as a resource itself, or deploy local chunks, which is a feature requested particularly for those who are really working on developing their own charms. Most of the charms, normally the use case is taking a charm already defined from charmhub.io, but in some cases, because you are developing your charm, or simply because you really want to play around some stuff, you really need to deploy your local charms. So these are some of the main topics for the next months to be worked on the Terraform provider. If you are interested in this provider, or you have requests or proposals, or you just really want to know about us in this exciting project, please, you are more than welcome to visit our repo, Juju/Terraform provider, or you can simply go to the Terraform registry and take a look at the latest versions for the provider. So finally, where can you find us if you have any questions, want to know more about these different solutions to deploy your applications and operators using Juju and different ways? Please don't hesitate to reach out to us. We are on Mattermost in this chat.charmhub.io, and you can also find us in discourse.charmhub.io. You are more than welcome to send your questions, recommendations, or suggestions to any of these links. Thanks to you. Thanks for having me. Thanks for listening to me. And hopefully you will just go with your keyboard and start exploring the different options I have presented in these slides for you. Please remember that if you have any questions, you can add your questions to the chat and they will be answered as soon as possible. Thanks a lot.